Hello, my name is John Machala, and today we'll be looking at a case study of the envelope system of the Astana National Library in Astana, Kazakhstan. The building is being developed to replace the existing National Library in Kazakhstan and is part of a movement to establish a new cultural identity for the country of Kazakhstan through a number of large commercial and government projects. The building is designed by Bjarke Ingels Group, aka BIG, which is a firm of mostly younger individuals from Denmark who have come up with a number of imaginative projects in the past. Prior to looking at the building itself, it would be pertinent to explore some of the climatological differences between the nation of Kazakhstan and the United States, specifically Florida. The nation of Kazakhstan is situated between the Middle East and Russia, and as a result lacks large concentrations of greenery and is rather much more rocky. This creates a climate that is much more dry, cold, and arid compared to what we're used to, and as a result, things like heat gain and natural ventilation of excessively humid air that we would frown upon are instead encouraged and beneficial. Also, at this point in time, we're going to be looking at the computer model, so those 3D glasses that were provided, you can put those on now. Thank you. Now, the primary form of the National Library is that of a Mobius strip, a three-dimensional Mobius strip, meaning that after one full rotation in the building's plan, the ceiling has become the floor and the floor the ceiling. Now, this is accomplished by a very structured repetition of the same form. The form in this case is a rectangular steel frame that stands vertically 170 by 90 feet. There are 36 of these, so in plan view, each one is deviated 10 degrees from the one before for a total of 360 degrees. In elevation, however, the deviation is half of that, 5 degrees, so that after one full circular rotation in plan view, the ceiling has become the floor, and the floor the ceiling. The steel frames are the basis from which the other pieces of the building's envelope system are derived from. The long side of the steel frames, the 170-foot side, is divided into 8 bays, and the short side is divided into 5 bays. So, along the divisions of the bays is where the intermediate members are placed between them, and that goes for both the short and long side. The glazing fits into grooves that has been cut into the members, both the primary steel frames and the intermediate members, and is placed in a point-to-point basis, which means that every single piece of glazing is different from every other piece of glazing. Now, the point-to-point glazing is the first layer of the building's envelope system. However, there is a second additional layer. Wrapping the entirety of the building is a grid system of triangular fins. The fins themselves within each grid square are 2 layered one over another and are angled. This creates a very dynamic facade of openings and opaqueness. The fin system extends beyond the glazing a few inches. Now, the fins themselves also have photovoltaic qualities, although specific details on that particular system were unavailable. The fin system is attached to the short side of the rectangular steel frames with a very small I-beam that is attached to the exterior. This concludes our tour, so to speak, of the Astana National Library in Astana, Kazakhstan. I pray that the various aspects of the envelope systems that have been modeled for you show you clearly how the various aspects of the envelope system have been layered together to create a facade that is both interesting and dynamic. Thank you for watching.